Hello there, Mr. Sutton here, bringing you the BC Calculus 7-4 Extra Practice Number 1 Solutions on Taylor series. For this problem, we want the third order Taylor polynomial about x equals 1 for this function. So let me get f of 1 to start with here, because I'm going to need that and 3 derivatives of this thing. So f of 1, that's just going to be 1 minus 2 plus 4, so that's going to be 3. Now we need f prime evaluated at x equals 1. Well, f prime is going to be 3x squared minus 2, and then we're evaluating that at 1. That's really just plugging in 1. We have 3 minus 2, which is 1. Well, that's nice. Next up, we need f double prime. That's going to be 6x evaluated at 1, so that's 6. And finally, f triple prime of 1. Well, all the derivatives of f triple prime, those are going to just be 6 if you take the power rule there. So that comes out to 6. And then anything after that's going to be 0 anyway, so it's just as well we're stopping here. All right, getting my approximation now. I've got f of 1, which was 3, plus, now I need f prime times x minus 1, so that's 1 times x minus 1. Then we'll have plus 6 times x minus 1 squared over 2 factorial. And finally, 6 times x minus 1 cubed over 3 factorial. And since these are, this is algebraically equivalent to whatever the answer is, I actually don't need to simplify this. It's okay just to leave the x minus 1 inside the parentheses here. For this multiple choice question, we were given the function sine of x. We want to know what's the fourth order Taylor polynomial if we have x equals pi over 2 as our center. Well, let's start with f of pi over 2. So that's just going to be sine of pi over 2, which is 1. And now we're going to need to take up to 4 derivatives of this thing. Unfortunately, it's just sine, so that's not too bad. First derivative is cosine. Evaluating cosine at pi over 2, that's going to be 0. Next derivative is negative sine of x. Evaluating that at pi over 2, that comes out to negative 1. After that, we've got negative cosine of x, which cosine is always just 0 at pi over 2. And then finally, these derivatives are flying by. Fourth derivative, we get back to the original function, sine of x, which means we again have a derivative of 1. Now plugging this in, our formula, we have f of pi over 2, so 1. And then we would do plus f prime times x minus pi over 2, but f prime is 0, so we don't write that term. Next we have minus x minus pi over 2 squared over 2 factorial. And then the next term is going to be 0 because of our third derivative. Next we have fourth derivative, which is 1, times x minus pi over 2 to the fourth over 4 factorial, and we're adding that. We've got positive 1. And this is it. This is the fourth order. We took 4 derivatives. There we are. Let's match the answer choices now. So we need a 1 minus, and that narrows it down to C and D. Then we need a plus after that. Only it's got to have these factorials on the bottom as well. So that would give us choice C. On this problem, I want the first 3 non-zero terms and the general term of a series generated by 1 over 1 plus, or 1 over x plus 1 at x equals 2. All right, so let me find f of 2 and also the first 3 derivatives, and I'll plug it in my Taylor formula. So f of 2, that's just going to be 1 over 2 plus 1, so 1/3. Now this function I could represent as x plus 1 to the negative 1, so the first derivative of that is going to be negative x plus 1 to the negative 2, and then we're evaluating that at 2. I've really got, this is always going to be 3 inside here for all these derivatives now, so this is going to be negative, let's see, 1 over 3 squared, so negative 1/9. Next, I need the second derivative. That's going to be 2 times x plus 1 to the negative 3rd. And that's going to come out to, let's see here, this is going to be 3 to the negative 3, so this is really 2 over 27 when all is said and done. And they said first 3 non-zero terms. Well, I've actually got 3 non-zero terms. So I'm going to stop taking derivatives and start writing my series. So I've got 1/3 minus 1/9 times x minus 2, or I can put that over 9, I guess, either way. Plus 2 times x minus 2 squared over 27, but we also have a 2 factorial down there as well. So don't forget about that 2 factorial in the denominator. And now, in order to write the general term, I don't really see a pattern readily apparent. I'm going to simplify things a tiny bit. I've almost got a pattern, though. So I've got 1/3 minus x minus 2 over 9, and then these 2's can cancel. So this is x minus 2 squared over 27. And at this point, I'm starting to see a pattern. All of these denominators, these are all powers of 3. This is 3 to the first, 3 to the second, 3 to the third. So it looks like the power of 3 is lagging 1 behind the exponent in the numerator. So when I write this all out, first off, I've got a -1 to the n so that I get some alternating going on. But I'm also going to have, upstairs, I'm going to make this, let's see here, x minus 2 to the n. And downstairs, this will be 3 to the n plus 1. So there we are. On this problem, I'm starting with sine of x, and I want to figure out which series is generated by sine of x at x equals pi over 2. So let me generate my series over here, at least a few terms, and then we'll start expanding these sigma forms until I get something that matches. So I've got f of pi over 2. That's just 1. I'm doing sine of pi over 2. Next, I have the derivative, which is cosine. At a value of pi over 2, that's going to end up being 0. After that, the next derivative is negative sine, so that comes out to -1. And then after that, we have negative cosine. At pi over 2, that's just 0. And finally, we have back to sine if I take the fourth derivative. But I actually don't need to go that far. Let me just do what I've got here. So I've got 1, that was f of pi over 2. I'm not writing down the f prime term. I've got now f prime of this stuff times x minus pi over 2 squared over 2 factorial. And I could do more terms pretty easily, but let me take a look now at what I've got for these sigma forms and see if I can eliminate any answers. So for this first one, let me plug in 0 to see what happens. So that's actually going to give me 1 for this. This numerator is going to be 1. Down here, I've got 2 factorial. Well, actually, no, I've got 0 factorial because 2 times 0. So that's also 1. This whole thing comes out to 1 in the beginning. And then for my next term, plugging in 1 for n, that's going to be negative x minus 2 squared over 2 factorial, which is exactly what we have here. Before I go ahead and pick this answer choice, though, let me do the first 2 terms or so of the rest of these and see if I can eliminate everything else. So for this next one, plugging in 0, this is going to be just positive 1. This is going to be kind of interesting. I end up with x minus pi because that 2 times 0 plus 1 is a power of 1. The stuff down here is 0 factorial, which is just 1. So I end up with then x minus pi over 2 for my first term on this one, which means that this is a no. It does not match the first pattern here, the first term. For this next one, plugging in 0, I've just got, this is just 1 because of the 0 power over 0 factorial. So that's just 1. For the next term, if I plug in 1, I'm going to have x minus pi over 2 squared over 2 factorial. And I'm adding that. So that's a little bit different than this part because we were subtracting. So this one can be eliminated because it has the wrong sign for that next term. For this part D, this just ends up being 1, all of that, if you plug in 0 for those exponents. The next term is just going to be, let's see, we're doing minus x minus pi over 2 squared. This doesn't have the 2 factorial, so it also has to be eliminated. And for this last one, we've got 1 for the first term. Next term is going to be, let's see here, x minus pi over 2 squared. That also does not have the 2 factorial in the denominator, and it's the wrong sign, so we can eliminate that one too. So that means it has to be choice A. On this question, they want to know the coefficient of x minus 2 cubed in the Taylor series for f of x equals ln of x, about x equals 2. So for this one, I need to figure out what the coefficient should look like. I don't really necessarily have to generate everything in the series, but let me see what I'm aiming for here. So to get the third power coefficient, that means I need the third derivative of 2 over 3 factorial. So this is what my x minus 2 cubed coefficient ought to look like. I've got almost everything I need actually to just write the answer, but I do need to know the third derivative of ln of x at x equals 2. Once I find that, I can plug it in and I've got my answer. So we've got the first derivative, which is going to be 1 over x, or x to the negative 1. The second derivative of ln is going to be negative 1 x to the negative 2. And the third derivative, which we're now going to evaluate at x equals 2, that's going to be 2x to the negative 3, evaluated at 2. That's really 2 over 2 cubed, which is 1/4. Plugging that back in, I'm going to have 1/4 over 3 factorial. And I could write that as 1/4 with 3 factorial in the denominator. I could leave it like this because these are all constants, but if I wanted to, I can turn this into 1 over 24, 4 times 6, and there is my coefficient.